Okay, so we're looking at 7.5, midpoints and diagonals of quadrilaterals, or in quadrilaterals. I want to look at this first review question here. Draw a counterexample, and we looked at this last day. A counterexample is a way to disprove a conjecture or hypothesis. So I'll draw a counterexample to disprove the hypothesis that all quadrilaterals with a pair of equal and opposite angles are parallelograms. And you always want to watch out for, words like all, right? All quadrilaterals with a pair of equal and opposite angles. So a quadrilateral, let's break that down. A quadrilateral is just simply a four-sided shape. So let's draw a four-sided shape that is a quadrilateral that has a pair of equal and opposite angles. So I'm going to start at the origin. I'm going to go up try and go up three units here. And it'll do the same thing here. So now we've gone up 3 units, and now I'm going to purposely go only 2 units this way. Not exactly what I wanted there, but almost. Okay. Not as easy as it looks in this program. It might be a little bit short. There we go. So what I've drawn is somewhat of a kite. I've got those two sides being equal, and I've got these two sides being equal. Please use a ruler when you're copying this the handout. So which of these angles are equal in the kite? And you'll notice it's actually these two right here, this one and this one. But this angle is not equal to that angle. And we know that because, as I mentioned at the beginning, I purposely went up 3 units here. So this is a smaller angle than this one because this one is a little bit wider. We've only gone down, it's a little more shallow, and we've gone down 2 units. So because of that, we only have one pair, and that's why I wanted to highlight that there, a pair. There's only one pair of equal angles here, not two sets of equal angles. So just by highlighting that, we break down the question. Sometimes on a test you might be stuck and you're wondering, oh my goodness, I don't know what to do here. Break down the question. What is it actually asking you? And sometimes it does give you more information than you think. Okay, look at the next question here. A PS4 system costs $399, goes on sale at 35% off. And what is the sale price? So there's multiple ways of approaching this question. One of the most common ways is just taking your purchase price, or the original price, in this case is $399.99, multiplying that by 0.35 or 35%. And if you do that, you're going to get $139 and about 99 cents around there. And if you take your $399.99 and minus your $139.99, so you'll start again, $399.99, take away the amount that you're getting discounted, you're left with $260. Okay, that's method 1. Again, also a very common method. Method 2 will save you a little bit of time. And what method 2 wants you to do is realize that if a product is on sale for 35% off, then how much of the product are you actually paying for? You're paying for 65% because 35% plus 65% is 100%. So if 35% if the price is 35% off, then technically, in other words, it's 65% on. That's the amount you're paying. So $399.99 times 0.65 will just give you straight up the amount that you're actually going to pay. And if you calculate that in your calculator, you'll get $259.99, which is really $260. Okay, so 2 methods. I think the second one's a little bit more efficient, but of course anything works here. Either of those 2 methods works. Identify 3 integer ordered pairs on this line. So we're given the equation, and we want to find ordered pairs. It just means let's find coordinates on that line. Well, the simplest way to do this is to just plug in any number for x and solve for y. But if I'm going to find ordered pairs, instead of subbing in, for example, 1 for x and then solving for y, what I might do to make my life a little bit easier is rearrange my formula first into y equals. So I have 5y equal, and we're going to bring that over, I'll get negative 3x plus 18. So I'm kind of putting it into y equal mx plus b format here, right? Divide both sides by 5, and I get y equal negative 3 over 5x plus 18 over 5. Okay, so here we go. Let's plug in a number for x. So if I plug in, let's plug in 1 for x, I'd get y equal negative 3 over 5 times 1 plus 18 over 5. And so that's going to be negative 3 fifths plus 18 fifths. What is negative 3 over 5 plus 18 over 5? That's going to be 15 over 5, which is really 3. So when x is 1, y is 3. Okay? And what I want you to do, I want you to come up with your own ordered pair. So you plug in different numbers that you think are going to work and find out what the ordered pair is. It really doesn't matter if the ordered pair has a fraction. They don't have to end up being whole numbers as long as you plug in any number for x, solve for y. And I'll look at your work next day and we'll take a look at that together. All right, which line segments in this diagram are parallel? Well, if you look at the learning goals here, the first one highlighted in green tells us that the diagonals of a parallelogram bisect each other. And then joining the midpoints of the sides of any quadrilateral produces a parallelogram. So what's important to us here is the second one. So we have the second one right here, that when you're joining the midpoints, these are the midpoints. E, F, G, and H are the midpoints of quadrilateral A, B, C, D. I'll highlight that as well. So we have A, B, C, D. The midpoints of that quadrilateral are E, F, G, and H. And when you join the midpoints, it produces a parallelogram. Well, if we're told that that indeed is a parallelogram, then we know that this line must automatically be parallel to the side opposite, and this one here must be parallel to that one there. So we're going to say that line EH, and the short form for that is by writing capital E, capital H, and drawing a line over it. That just means, or that reads, EH, or line EH, is parallel to F, or line FG, and we know that line EF is also parallel to line GH. And that's because we know that, again, joining the midpoints of the sides of any quadrilateral produces a parallelogram. But how do we know that the midpoints were joined? Well, let's just take a look at the diagram. We have these hash marks that show us that E is the midpoint. And we have this hash mark here that shows us H is the midpoint. And of course, we have the hash marks here to show us that G is the midpoint. And we have these three here and these three here that show us that F is the midpoint. That's how we know just by inspection that indeed those are the midpoints. All right. Calculate the lengths of PT and ST given that PR measures 14 meters and QS measures 10 meters. So basically, we know that line PR is equal to, 14 meters. So we know that line PT has to equal 1/2 of that, or 14 divided by 2, which is 7 meters. And the reason we know that is because what's written in green here, the diagonals of a parallelogram bisect each other, which means they cut each other in half, or 2 equal parts. So, and then we're told that QS is equal to 10 meters, and so if QS is equal to 10, then QT, ST in this case, which would be right here, just S to the middle, ST, line ST is going to equal 10 divided by 2, which is 5 meters. You'll notice that I didn't write meters right over here. I didn't write meters in here, right there. And the reason is because we don't want to write that in the actual question. At the end is fine as the final answer, but we don't write that in the actual calculation. Okay? For each statement, either explain why it is true or draw a counter example to disprove to show that it's false. So any diagonal of a quadrilateral bisects its area. So any diagonal of a quadrilateral. Now, if I drew a parallelogram and I took a diagonal, that bisects its area. If I decided to draw the other diagonal, that also bisects its area. So in this case, it looks like it's true, but is there a quadrilateral that we can draw where that would not be true? And so one that you might come up with is a trapezoid. Because if I draw, you'll see the pink line, I drew the trapezoid in green there, and the pink line on the diagonal, you can tell that shape number one and shape number two are not, these two triangles are not equal in area. Okay? And so in this case, it does not work. Then the second part here, B, says any line segment joining the midpoints of opposite sides of a parallelogram bisect its area. And normally that would work. If I take a regular parallelogram and I join the midpoints of the opposite sides, that would work. If I took this midpoint and that point, that would work. We cut the area in half. But in this case, this would not be the case if you have a trapezoid, because you'll notice that obviously this part here is longer, has a longer base, and this part here has a shorter base, and they both have the same height. So in this case, we have an exception to that rule for any line segment. Again, the word any line segment joining the midpoints bisects the area. In a trapezoid, there's an exception that doesn't always work. Okay? All right, so we'll take up the questions that I left for you in this handout next day. Good luck with the homework.